What's up, guys? One more to go. I've moved it on into the bedroom, to end the night. So let's see what we got going on here. Well, we're going from nanoliters to liters. And once again, let's color code this ish. Nanoliters are small, really small. So let's do them in a cute little, let's just do yellow. Ah, ew. Nice try, nanoliters. Pink. Nanoliters. And we're going to liters, which is the base unit. So again, I'm going to do the base unit in blue. So I've done grams, meters, both in blue, and now I'm doing liters. Grams, meters, and liters are all the base units. I'm going to do them all in blue because when you take into account the prefixes, they're all three of those are really the same thing. Okay, so we're going from nanoliters, which is way down here, the smallest one we really have to worry about, 10 to the negative ninth meters per nanoliter. So, well, right there's our conversion factor, or one of them, possible ones. So we have 10 to the negative ninth, I think I might have said meters, 10 to the negative ninth liters, same thing, per, what color did I do? Pink. Per every 1 nanoliter. But again, I don't like using that, so I'd much rather say there is 1 liter per 10 to the ninth nanoliters. So it takes 10 to the ninth nanoliters to equal 1 liter. There are 10 to the ninth nanoliters. That's a lot of nanoliters per 1 liter. Okay, and this is all we're going to need to solve this right here. One of these, you can use either one, whichever is more intuitive to you. So what do we know? Well, we know that we're starting with 35 nanoliters, so that's the first thing we write out. And now we only need one conversion factor, so it's going to be times something equals, we want our final answer to be in liters. So one thing to think about right now is, are we going to end up with a number larger or smaller than 35? So take a second right now yourself and think about that. Think about what you think the final answer is going to be. ASMR. Okay, so hopefully you thought a little bit about what you think it's going to be, and now let's do this. So again, I like to stick with the positive number exponents whenever possible. So the first thing to think about is, what are we trying to get rid of? What are we trying to lose and change? Well, we're trying to get rid of nanoliters. So we drop it like it's hot. It goes down to the bottom. Okay. Some people call this the railroad track method, by the way, where they put lines like this. And then like when you have a double conversion like we did up here, you'll have these lines. And it's like you put this stuff, and you're always dropping like it's hot, whatever you're trying to drop. So feel free to do that if you want. I never really have. I just do the fractions. Up to you. Whatever. Do what you want. I don't care. Okay, so we're trying to get rid of nanoliters, keep liters. So this is our first and final conversion factor. So we want what we're trying to keep in the numerator. Okay, so if we set it up like this, then we can use either one of these. I'm going to use this one right here. 1 liter per 10 to the ninth nanoliters. Okay. You're just having my phone calculator is going to come back to bite me. Okay, so all you need to do here is 35 divided by 10 to the ninth. And you're going to get your answer in liters. The other thing you can do is you can go here, and it's 10 to the ninth. So we're going to go, we're going the other way, because if you thought about it, this number is going to be a lot smaller because we're going from a very small unit of measure. So again, if we have a line here, and we were measuring it with nanoliters, which are tiny, you're going to have a bunch of, okay, so the number is going to be high. You're going to have a high number of nanoliters. But then if you go to a bigger unit of measure like liters, again, this is a linear distance example, whereas we're really measuring volume here. But you get the idea. So there's a ton of little nanoliters in here with just a few liters. So this number is going to get a lot smaller. So this is where you say, okay, well, we have 10 to the negative ninth meters per nanoliter. So we're going 1, 2, 3, 4, 5, 6, 7, 8, 9. That was not very pretty, but that's okay. So my decimal point is going to be here now. I'm going to fill in all of these spaces with zeros. So it's a big number, a lot of zeros. So the easier way to do that is to write it in scientific notation, which means it has to be 3.5. Don't leave it as 35. You have to do 3.5. So from here, we have 1, 2, 3, 4, 5, 6, 7, 8. 3.5 times 10 to the 8th liters. Okay, so that is the answer to the third one. Conversions, hopefully not as scary as they initially seemed. Write the answer right here, 3.5 times 10 to the 8th liters. Oh my goodness, I made a dumb mistake that I hope you guys caught. That I just did. Okay, hopefully you caught it. Makes you smarter. I just put that as a positive exponent. However, clearly we have a number here less than 1, and we're moving the decimal to the left, so this should be negative 8th. Okay, because we want a much smaller number, like I said initially. So that was a dumb mistake on my part. But hopefully you guys followed that pretty well. The metric system is nice because it is all by the power of 10. So like for this last one, we started at nano, and we had to go 1, 2, 3, 4, 5, 6, 7, 8, 9. I put these little lines in here to show you that because from milli to micro, micro to nano is actually 3, not just 1 for the exponent. So I put those extra lines in. But you can see that it's 9 jumps. You have to move your decimal 9 places for each of those. Okay, so hopefully you followed that pretty well. And that's it for this. There are plenty of examples out there. You can make up your own examples to do it. Hopefully you guys still have that conversion worksheet, which unfortunately I didn't have with me. I couldn't find on my laptop, so I must not have saved it there because it was a while ago before I was really integrating all of it. Anyway, blah, 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 blah. I wanted to do some problems for that, but I couldn't. It's okay. These problems work just fine. I will see you.